All right, so we're sort of in the heart of, no, the heart. We're at the beginning of chapter 6, really the beginning of the three chapter wide unit on trigonometry. And we're starting with homework 25 here, and this would be problem 32 on 379. You've got two similar problems to do, 33 and 42. And they're similar to this problem, which says find the exact value, and that does not mean use a calculator, of sine 30 minus cosine 45. So I'm called this using the unit circle. We could call it a lot of things, but I just so happen to have a unit circle laying around. So let's see how a unit circle can be employed to find these things. Let's actually start with cosine 45, just because it's a little easier for me to draw a 45-degree angle here on the unit circle. It's much easier to draw than it's going to be to erase. But remember that what's cool about the unit circle is that this side of the radius is 1, so it's called the unit circle. And if I draw this little triangle right here, the length of this side is actually the sine of 45 degrees. And the length of this side is actually the cosine of 45 degrees. So how the heck does that help? And in fact, this point then is the point. The x-coordinate is cosine 45 degrees, and the y-coordinate is sine 45 degrees. So now actually we've got to kind of leave the unit circle and get back into some basic geometry. This 45, 45, 90 triangle, right? It's maybe right off the bat you can remember that the sides, if the hypotenuse is 1, the sides are 1 over root 2. And if you can't remember, the sides are the same. This thing is an isosceles triangle, so if we call both sides x, the Pythagorean theorem says that one side squared plus the other side squared is equal to the hypotenuse squared. That's 2x squared is equal to 1. That's x squared is equal to 1/2. That's x is equal to 1 over root 2. I won't say it's plus or minus root 2, but in fact it is. So if that's the case, at 45 degrees, this actually becomes 1 over root 2 minus 1 over root 2. Not minus, I'm sorry. This is an ordered pair, so it's 1 over root 2, 1 over root 2. The sine of 45 degrees, the cosine of 45 degrees is 1 over root 2. So I'm just going to write 1 over root 2 right up here. And now I'm going to go to work on what the sine of 30 is. Maybe I won't make too big a mess if I draw this triangle now with this angle 30 degrees. And I'm just going to pull this little special triangle out. He's got a sine, an angle of 30 here, an angle of 60 here, and an angle of 90 there. And these little so-called 30, 60, 90 triangles have the property that if the hypotenuse is 1, the short side is 1/2, the long side is root 3 over 2. And in fact, you can see that root 3 over 2 squared plus 1/2 squared is equal to 3 over 4 plus 1/4 is equal to 1. And that's what you'd expect. This side squared plus this side squared is equal to 1. So if that's the case, and if indeed this length is the sine, then that says that the sine of 30 is equal to 1/2, and the cosine of 30 is the length of this side, which is root 3 over 2. So this point right here, sorry that we've got all this jammed in here, but this side is, the x-coordinate is the cosine of 30, which is, let me just write it like that, cosine of 30, the y-coordinate is sine of 30, and those numbers are actually root 3 over 2 and 1/2. So what am I looking for? Sine of 30 is 1/2. Let me just get back to the black marker here. Sine of 30 is 1/2. So now all I have to do is sort of clean that up. Common denominator is 2 root 2. This is a shy of root 2. This is shy of 2. For whatever reason, I'm going to multiply top and bottom by root 2, and I'm going to get 2 minus 2 root 2 all over 4. The root 2 times the root 2 produces a 2 times the 2 is 4. And that will leave me 1 minus root 2 all times 1/2 is probably the best way to write that answer. Yeah, we spend way too much time on that problem.